Vamos continuar então agora, pessoal, com vocês o Thibault.
Bate, é mim?
Adobe.
Obrigado. Boa tarde. Meu nome é Thibault, ou Thibault, português style. So I'll speak in English. I wish I could speak in Portuguese. I'm very excited to be here. First time in Brazil. I'm from Adobe, coming from San Francisco. And actually, before we start talking about the technical stuff, I want to tell you a little story about my relationship with Brazil. So that's my record collection in San Francisco so far, no relationship with Brazil. But I collect black music, disco music. And you guys produce some pretty good stuff. Amigo de New York, de Nova York? I know this one. Sandra Sa, vale tudo? Sí. Edmota. Hoje tuta Edmota. There's a guy here that looks like Edmota. Where is he? Afude. I had no clue Edmota was so into JavaScript. It's amazing. You guys are awesome. And of course, palco, Gilberto Gil. So basically, music, food, drinks, dancers. So you have to adopt me. Okay, so that's for the story, and it's real. Seriously, I listen to that music, and I need to find a shop probably this afternoon to go buy some records. So what does Adobe does on the web? So as I said, I'm from Adobe. I work on the web platform team. And what we do is we contribute innovation into the stack, the web platform stack. And we did some contribution already. We contribute to Blink and Gecko, the engine powering Firefox. And WebKit, we have some WebKit reviewers, and we contribute specs like CSS regions, you may have heard of, which is for next generation layout for the text. Something we're pretty excited about, or CSS custom filters. And so we're also developing tools. The reason why we also contribute on the web stack is because we want to be able to have the web platform more expressive so that you guys can create awesome stuff and express your ideas on the web. For us, the web is just another canvas for, creative people. So if you want to have a look at what we're doing, this is the website, html.adobe.com, and this is all, you'll find all the details on our contributions. So we're here to talk today about JavaScript concurrency, and concurrency is a fancy word for multi-threading. Basically, the idea of running multiple computations at the same time in your program. Who has ever heard of multi-threading? Okay, awesome. So in JavaScript, it's pretty new. The concept of multi-threading is not really, it's actually something pretty new because now we have the capabilities to do that, and we're going to have a look at that. So far, by default, JavaScript is a single-threaded world where when you put your code, it executes with the rendering and other things like network calls. And then at some point, if something takes too much time, the browser is going to say, hey, watch out, there's something weird here. We should stop that. It's blocking everything, the input, the execution thread of your script. But to be fair, you don't necessarily see that too much today, except when you have a bug or infinite loop. But what you see sometimes is here coming from an iPad, and then when you touch the screen, there's a computation, and it locks the screen. This is basically locking the UI thread. So you have your smooth animation, you're super happy, 60 frames per second, and then suddenly, boom, there's a hiccup. There's some problem. How many of you guys have seen that happening in your programs? Yep? Okay. So the most important thing to remember as a developer who care about performance is the concept of budget. And this is actually from Google I.O., one of the the Chrome guys actually from the performance team wrote that on a big whiteboard, and people could join the conversation, and it was all about performance. And so the budget is basically how much time do you have per frame to do what you have to do. Network, script, all the things that you need to do. It's not a lot. 16 milliseconds is not a lot. Oh, sorry, question? Okay, we'll take a question later. So if you were targeting 30 frames per second, you would have, around 30 milliseconds. So 16 milliseconds is not a lot. So you take a frame, and your frame runs on the UI thread, and this is what Josh mentioned as part of the tools in IE 11. You have this UI responsiveness feature that tells you, how much load do you have on the UI thread. So let's say you have 6 milliseconds in JavaScript. You're doing some computations. You have 2 milliseconds on the network, and you have some CSS and stuff that codes the repaint and reflow, and you have 8 milliseconds. It gives you 16 milliseconds. It's good. You're under budget. You're going to be rocking at 60 frames per second. Now, you have more stuff. You need to parse a file. You need to compute the collision between objects in a game, or you need to encode a PDF, or you need to do something a little expensive. Then you're going over budget. And then there's a UI impact. So right there, 10 milliseconds, what's going to happen is that visually you're going to see the UI stutter. And you don't want that, because then the client or your customer is going to be like, I don't know, when I click, look, there's a little hiccup. And you don't want that. You want it to be super smooth. And it's not necessarily the fault of JavaScript. You could have more stuff on the rendering side, doing some canvas, DOM manipulation, expensive. It's pushing you over budget. And what you want to do is probably move as much as possible stuff off this UI thread. And what? Well, rendering you can't, because rendering happens on the UI thread. The good news is that web workers will allow you to move network and JavaScript off that in a different thread. So that way you can do whatever you want. It will never impact the UI. So this is what it looks like in a dev tool like Chrome. Firefox has the same thing, and many browsers. i11 has some awesome stuff that they release. But basically, you have this timeline, and you see these bars. And this is actually on the right. You see the impact on FPS. It's a small capture, I'm sorry. But basically, it says 60 frames per second here and 30. And you can see that actually here it goes beyond that point. We're spending 18 seconds. So obviously, yeah, at this point, you got a little lag on the UI. So you can see that pretty clearly now with the dev tools. So how do we fix that? Web workers. Who we call web workers. So web workers are going to be super helpful. And the good news, very good news, is that it's really nicely supported. And so there's two flavors of workers. They're shared web workers. We're going to be talking about the dedicated web workers. Shared web workers are basically a different flavor that allows you to communicate better between different workers. But they are not really well supported. So I would recommend targeting dedicated web workers first. You see that there's a bad guy over there, Android browser. So I'm pretty sure these guys are going to be going to fix that. But right now, you have a really nice support across the board. So you can detect it manually. You can use Modernizer. Very simple. And so what it allows you is to enable progressive experience. And when web workers are enabled or available, then you can leverage them. And when not, you need to fall back. How do you fall back? Well, I'm sure you guys already use tricks like the timeout and callbacks, and you split the computation across multiple frames so that you make sure you don't do too much on a frame. Probably going to have some hiccups, but not a very important hiccup. You're going to have, maybe a few frames skip, but that's not that bad. But ideally, of course, you want to leverage workers. So the first thing to remember is web workers are extremely powerful for responsive programming. So whenever you have a problem with your UI and you see that you have a responsiveness issue, this is what responsive programming is about making sure that everything plays smoothly and you have no hiccup, you can leverage web workers. So as I said, by default you have the UI thread, and now we're going to have a web worker that utilizes actually another thread behind the scenes, and we'll get into that in a few minutes. You're going to be able to put your code, network, JavaScript. You can even have computations running for a long time. You'll never see a timeout. It will just run. And when it will be done, it will give you a callback. It will say, I'm done. It's cooked. Here's the data. So what kind of use cases? I'm sure you're already thinking about stuff in your application. Oh, yeah, I remember that day I had a file to generate. Let's say you're capturing something from the microphone with the web audio APIs, and then you need to compress that as a wave, or encode that as a wave file, or OGG. Well, this is intense stuff. Then move that into a background worker. More classic, you have some data coming from a XHR object, and then what you do, you parse that, and it's expensive. It's some, I don't know, an object that you loaded, a 3D file, or some fat JSON file. You want to parse that, then move it to a background worker. And then same for the physics. If you have some computations, you want to do AI or pathfinding, you have a game, and you want to compute something, move it to a background worker, so that way the UI is going to stay perfectly smooth. Of course, in a worker, you don't have everything. It's not another browser. It's not a copy of the browser. It's an isolated process that has all the JavaScript features, the language. So you'll have everything, loops and objects, and all the primitives and types you know. But when it comes to the browser, no DOM, no window object, no document. And no DOM, obviously, because you can't render in the background worker, because it happens on the UI thread. And you would have to handle, a DOM that would be shared across workers and stuff. You don't want to have to deal with that. So today, no access to the DOM in a background worker. What would be really cool, though, is have access to Canvas. I think, actually, I've seen some conversation about that going on, which will allow you to paint stuff off screen for dynamic sprite sheet generation, things like that. And then once you actually you're done, you have the object, the canvas buffer off screen. Boom, you transfer it on the UI thread, and then you can display it. So one very classic question I have is, web workers, so it's like threads, right? Well, yeah, in the way that it allows you to move stuff in a different thread, but it's not like threads. And it's actually, it's good. First, workers are way higher level than threads and safe. What does that mean? Well, how many of you guys have played with threads in Java or C++, right? And so I'm sure you understand the complexity of having access to shared memory and locking and race conditions and all that. And it makes sense when you're writing OS stuff, application, very low-level stuff. But for web development, you probably don't want to deal with that. And it's actually really good. So workers are extremely simple to use and safe. So it's limited in a certain way. We'll see how in terms of cost and memory and speed. But it's very easy to use. Like in 5 lines, you can move stuff to another thread, and boom, you have solved a problem, and you don't have to deal with problems you don't want to have to deal with. So how does that work behind the scenes? Well, when you create a new worker, you pass a file that has the code that you want to execute in the background. It creates a new JavaScript VM, essentially. And depending on the implementation, it could be a different process, but to make it simple, let's think about it as a JavaScript VM. So it has a cost in instantiation on memory, but it has its own heap and stack, so garbage collection happens separately. But what's really awesome is that it's basically another JavaScript engine running. So you have to think about also when you use workers on mobile, for instance, don't go and instantiate 20 workers because it's going to be super costly in memory. On desktop, you could do that, and actually in Chrome and other browsers, there's a security, there's a flag, I think it's 50. The 50, the browser say, hey, dude, chill. Actually, 50 workers, maybe you could, I don't know. But essentially, what a good practice is at the beginning of your application, you instantiate these workers, and they're instantiated and they wait. And you use them as a server, and you say, hey, do this. Hey, do that. You don't allocate them when you need them. Don't do that. Don't say, oh, let's actually move something to the background. Instantiate a new worker, done, kill it. Instantiate a new worker. No, the garbage collection is going to be like, hey, chill too. So you want to be able to create those workers, maintain them in memory, and when you need them, you pass information, they return the result. Second difference with threads, the way you pass data. As I said, let's say you're working with low-level threads, you have shared memory. Oh, yummy, some shared memory. Let's have all the threads work on it. Yeah, it's super powerful, it's fast. But when one is working on it, be careful because you don't want to have corruption. So you need to deal with lock and mutexes and all that stuff and conditions. Yeah, you don't want to get there. And usually, when you start messing with that, as a web developer, yeah, that summarizes it basically. And I totally agree with this discussion. A lot of people involved in this discussion and standards, and people saying there's got to be something better for web developers than shared memory. And I agree, and I know that the Mozilla folks are working on some cool stuff, thinking about that, so that's awesome. Okay, so how do they communicate then? We don't have shared memory? Well, they communicate through cloning or transfer of ownership. So basically, when you pass something to a worker, by default, it's cloned. So that's expensive. It's okay for most stuff you're going to be doing, like an array, but we'll see how we deal with bigger objects. And actually, for bigger objects, we have transfer of ownership. That's super powerful, very simple, and we'll see how that works. So before we get into the code, last thing is web worker equal one core. I was on Stack Overflow the other day, and people were saying, so wait a minute, if I create a worker, does it go into a different core if I have a multi-core machine? Well, for the context, on a single core CPU, stuff doesn't happen at the same time concurrently. There's something called context switching. Everything happens very quickly, so you don't notice that things don't happen in parallel. But nothing happens at the same time. With multi-core CPU, you can have multiple threads, and yes, it's going to happen concurrently, truly concurrently at the same time. But again, as a web developer, do you really want to deal with that? Like, okay, if core, blah, 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 I'm going to do this, and then, oh, no, I'm going to do that. No. You want to leave that to the OS. So to summarize it's not possible to specify if a web worker should run on a specific core. But what's cool is that even if you run on a single core, you can still move stuff off the UI thread. It will not block the UI. And on a multi-core CPU, web workers can run truly in parallel if the OS decides so. So if the OS says, okay, right now I can move you to a different core because, and you can imagine the OS has a lot of things to manage. If he thinks that's the right time to move you to another core, then he's going to move you. But you can't decide. You can't specify that yourself. And I know there's been some libraries trying to guess and force that, and I don't think it's a good thing, but okay. Enough bullshit. Let's get to the code. No, I hope this was that helpful, the intro? Okay, awesome. Afude. Can I say afude like that? Like anytime? Okay. At the restaurant, afude. The waiter is going to be like, what? Oh, hey. Okay, not my grandma. Okay, cool. No grandma here. We're good. So we create a new worker, as I said, pass the background code. And then this is the background code here. This is basically what's in the background JS code. And then what you do is that you refer to the worker itself using self, or this, and you call it post message. And post message sends the data. Very simple so far. And then on the other side, what we do, we just add an event listener message, and boom, we get the data. It's very, very simple. As I said, you see it's very, very easy to use. Now, you're trying to access something that's not available in the background worker, triggers a runtime exception. Boom. How do you capture that? You listen to the error event, and then you get your error here. Okay, what can you pass? That is very interesting because you may want to be able to pass complex objects, crazy stuff. You can pass primitive types like number, string, Boolean. You can also pass plain JSON objects, which is very helpful. And they updated the spec recently. Initially didn't have image data. But because there's a lot of use cases with image manipulation, let's say you want to do image recognition, image face tracking, and you actually want to move that to off of the UI thread and move it to background worker. Then you're going to move your computation into background worker, but then that background worker needs to have access to canvas. So what happens is that what you can do from the UI thread, you can pass the image data object, the pixels, and then you can do the image recognition, the image processing on that image data, on the pixels in the background worker, and then return that back to the UI thread and display it. And then you're going to be able to actually do image manipulation. And typed array, also very helpful if you are working with binary data. One thing I tried is you want to be able to pass a custom type, have a class, person, or ball in a game. Doesn't work. Can't pass that, so you're going to have to pass plain objects. Okay, now we're doing something quite expensive in the background here. Basically, I'm just doing a while loop with a big number and doing a square. It's a slow square. It's actually an example from the parallel.js page, which is a cool library. And then when I run that, it logs the UI normally, but because I move it to the background worker, works perfectly. And if I apply that in my example, I click, computing, that should be locking all the way, but no, I'm using a worker. Boom, gets back, animation super smooth, and I don't have to worry. My application is responsive. So data cloning is expensive. By default, as I said, when you call post message, data is cloned. You pass a string, cloned. Pass an array, cloned. Everything's cloned by default. So you have your web worker A, and you post a message to web worker B. Note that we could have n workers. I'm keeping it simple here with 2 workers. And when I do that, when you do post message, data is cloned automatically. And so if I try to modify the data once it's sent, we're working with a composite data type here. So, normally if I modify this object, that should be reflected in all the references. But because the object is cloned, on the other side, it's already another object. We're not working with the same data anymore. If this would have worked, we would have shared memory. And so, again, keep in mind that, working with different objects. So obviously, there's a cost in memory. Let's say you pass every frame 100 objects. I tried that. Not good. On the request animation frame, I show you the example. Not good. And the browser was like, no, I can't handle all that many objects. So overhead when there's cloning. So if there's an overhead when cloning, let's say I'm working with a big object, like a 8 megabyte, a 16 megabyte byte array, and I load that into memory, and I want to be able to transfer it to a worker. You've processed a big image, or you're working with, I don't know, something big, and you want to transfer it, something coming from a socket. So what we do, we create an empty byte array, we fill it with fake data, ends up as a 16 megabyte byte array in memory, and then we send it. On pretty recent hardware, like even I tried on iOS 7 and iPhone 5, it's pretty expensive. On desktop, it's okay, But again, you have to think mobile first. And if it runs great on mobile, it's going to run great on the desktop. So what you can do is use transfer of ownership. So we just saw data cloning, which is a default way to pass data. Now we're saying transfer ownership, which is the second way to do it, which is optional. And what you do is that you pass basically an array of the things you want to pass the reference to. And what happens is that in this world, I have my object, I pass the buffer, and here, I'm sorry, there's a typo, it should be data, but you get the point. As soon as I do that, the object is gone, the reference is gone, the pointer is gone, if you're thinking C++. And so on the other side, I will get the data, but on the other side, it's gone. That's why it's called transfer of ownership. That worker has lost ownership of the object. Performance, dramatic boost, almost a 3x boost. So you see that it was 214, big boost on iOS 6, and also 2 times faster on the desktop. So as an interesting use case, parallel programming. So we just saw responsive programming, which is the idea of making your application more responsive, moving expensive computations to another worker, another thread. But there's something really interesting called parallelization and parallel programming. And parallel programming is different. It's not about keeping the UI responsive. I mean, ideally, yes, it's on top of that. You could have parallel programming on top of responsive programming, obviously. It's when you want to leverage multiple CPU cores by having computations running at the same time. So imagine you have an object, you have a canvas, and you want to do face detection. You're going to be splitting the canvas in 4 or n objects, n surfaces, and have each worker work on this surface concurrently so that you can finish the work faster than if only thread would be working. That's super powerful because imagine you can leverage multiple threads, multiple cores to do things and solve problems faster. So let's say I have this beautiful image. And I want to do an image processing on it. I can have different workers get a portion of the screen, of the image, and work on it. Or if I have an application, a game, and I want to be able to detect collisions between objects, maybe I can have not one thread working with all the objects, but have multiple workers get a specific area and work on that area. But maybe you see already the problem is that I have a lot of objects here, a lot of data. And so cloning overhead is high and can really limit the parallelization opportunities. For instance, in the example with the balls, having access to the different, having the different workers have access to the same array of objects is not possible at the same time because we don't have shared memory. So what you could do is pass the objects over the different workers each frame and have them process that. Super expensive because there's cloning. And so you could think, well, then I can transfer ownership. But then no, transfer ownership only allows one worker to work on it at the same time. So then there's no parallelization. So transfer ownership is not really obviously designed for that. So essentially, there's a better communication model that needs to be designed for that. And again, as I said, I'm sure we're going to get there. There's some interesting conversation coming from a lot of different companies about that. There's also some initiatives like River Trail from Intel that goes even beyond that allows you to do parallelization from the GPU, because you can also use GPUs for that. So maybe what we call STM, so software transactional memory, or maybe some flavor of shared memory would be possible, even if I agree that it's not the best. We have to find something so that we web developers can do parallelization with web workers. Again, today they're really designed more for UI, responsive programming, than parallelization. But I invite you to experiment. I've seen some interesting articles about, trying to do parallelization, but you'll realize that sometimes the overhead of cloning, the overhead of creating the workers, of passing data, actually is not worth it, because then you basically shadows the benefits of parallelization because of this overhead. Okay, so let's see if you remember the main points. How much time do I have left? Awesome. Okay, so to summarize, and I want you guys to, participate. So first question, can I leverage web workers if I don't want my UI to lock? True or false? Yes, that's correct. Web workers are available pretty much everywhere on desktop and mobile. True or false? Well, if you're an Android user, it's false. It's actually true. Only right now, as far as I know, the Android browser doesn't have support. And maybe Google guys already pushed an update in the past. I don't know, but check. But it's really well supported. So you have no excuse. You can start using them today. Oh, damn it. You haven't seen anything. Web workers are as low level as threads. True or false? Yeah. I can say a fude. Huh? Okay. Message cloning is faster than transfer of ownership. True or false? Yes, it's false. Message cloning overhead, so transfer ownership is faster. Web workers work great to keep the UI responsive. Who are you? Oggi tutta. Onge tutta, right? Onge tutta. And I know it's two here. Okay, parallel programming and responsive programming are the same things. Exactly, it's false. Parallel programming is running computations to solve a task concurrently, to have it run faster. Responsive is all about keeping your UI smooth like butter. Thank you very much. And this is my slides. Obrigado. Obrigado. And, there's one. Can we keep the slides up just for a second? So this is a copy of the deck that I'm using. This is my Twitter. If you want to chat, you're lonely at night, we can chat. And then more details. It's basically an article that I wrote about concurrency. It has some more examples, more details. And if with Google Translate, you can get it in Portuguese and have that for free too. Yes. Any questions? I can actually ask people questions. You over there. That's actually awesome. I want a question from Ed Mota over there. That would be my dream. Come on, Ed.
You said people are looking at cheaper ways to do data sharing across multiple workers. Have they, do you know of any discussion about using immutable objects to share memory without cloning and without transferring ownership?
Yeah.
Since we have object.freeze, which kind of gives you immutable objects.
Well, yes, but it's explicit again. I mean, you would have to call freeze. You would have to do this thing explicitly to freeze. I think ideally you don't want to have that model to be exposed to web developers and have them, oh, by the way, yes, you completely screwed your memory. You didn't call object freeze. You should have done that, right? And I think I was talking to different people at W3Conf, And a lot of people have ideas on new models and how we could do things. It doesn't really imply using object freeze, but again, object freeze is something that you would have to explicitly call yourself, and I think the vision behind preserving with developers from this complexity is that it should be easy. You wouldn't have to use specific APIs to protect yourself, right? Okay. And this is the good thing with web workers is that it's really, really hard to screw things up, right? It's very safe. So I think we want to go in that direction.
Thank you.
Yep. Man, on stage.
I want to know who said to you about Ed Mota.
Okay, Ed Mota is my dad.
Ah.
No.
Are you from?
No, Ed Mota, I discovered Ed Mota from a friend who collects music from all over the world. And he introduced me to Ed Mota and a song called Lady. And it's awesome. I feel like I'm talking to Ed. And that's how I got introduced to Ed.
Okay. Thank you so much.
Thank you. That's awesome. Any other question? Okay.
Hi. Can you do something like fork join with workers?
No.
No?
No. So what would be your use case, for instance?
You talked about data partition, right?
Mm-hmm.
In parallel. Maybe you want to do processing partition and maybe do something and
no.
do the others.
You can clone, you can transfer, but you can't do much.
You can
stuff.
start 3 workers and then wait. Now do this only after these 3 workers are done.
Yeah, you could do that. You could do that, but again, you would have to program that. But you would never be able to share the same memory. So you can't have corruption. What you would be able to do is you have a worker, you have 3 workers, and one starts, once he's done, actually, he can actually pass a message to the other worker, and then actually have communicate to the other workers. You would have a lot of different events and callback triggered, but you can do that.
Okay.
But you would have to pass data all the time, and that data would be cloned, right? You wouldn't be able to say, hey, once I'm done with this chunk of memory, you worker start working on it.
So I think I was asking for like a guarantee that 3 works are done, you know. I think I don't know what.
Maybe we should let's chat after that.
Okay.
We can.
Okay, thanks.
Great.
Tomorrow.
Okay. Swarm. How do you say it? Swarm.
Hello. Okay, it's working.
Tá calor. Okay.
Tá bem calor. I wonder if you could have a web worker in the background, maybe listening to a WebSocket, and then when receives the data, using kind of a template to generate the HTML, and then passing to the UI. So the UI just have to render it, or just include the whole HTML somewhere.
So it's funny you said that. This morning I was checking, making sure that WebSockets were available from background workers.
Yeah.
And apparently it works in Chrome. I'm not sure. I think it works. But that's a great use case. You get the data from... Actually, I think this is one of the best use cases of web workers with data, is that you grab data from remotely. Yeah. And then you process it, and then you pass a string, and then you pass an XML object, and then you actually render it on the UI. That would totally work.
Cool.
Yep.
The last one.
Actually, you could use cloning or transfer of ownership once you're done. So it's like if it's a big chunk of data, you can just transfer it.
Hello. I would like to know how callbacks have run. In what thread do they run after being called in the what do I call it? In the worker? Like, if you call the callback and it has a lot of work to do.
Yeah.
Like, does it stay long and the web worker stays like hanged up at the time it was called in the callback. You call the callback, you send a callback for the worker to call after finishing the job. So how was the callback run? In the worker thread or on the UI threads?
Well, it runs in the environment where you're sending the message. So you're listening on the object. So you have let's say you have 2 workers, right? Okay. And so you do myWorker.addEventListener in the environment where you created the worker. So the allocation and the callback is actually dispatched on the environment where you actually registered for the listener.
So the dispatching is actually like not costly.
No, actually, it's not.
No.
It's not actually the costly part is the data that you transfer.
So when you call the callback, like simply you actually just lose the context, and the web worker calls the callback and doesn't have anything linked to it at the moment.
I'm not sure I understand.
You have a callback set to run after work is done.
Yeah.
By the web worker. When the web worker calls the callback, you simply call it and goes on with what it's doing. Or he has to wait.
No. You're done. You get the data and you're done. You don't have to do anything.
So dispatching is actually fast. Okay.
Yes. Obrigado. Thank you, guys.